In this video, we're going to learn about the scientific method. The scientific method is a series of steps used by scientists in every discipline in order to learn about the natural world. Now, whether you're studying biology, chemistry, physics, astronomy, or any other science, the scientific method always starts by asking a question. What is something that we want to learn about the world that we live in? In Science 9, it's probably easiest to start off with an example that we can visualize very easy. Let's say that you're rolling a pair of six-sided dice. We want to know what is the easiest total number that we can roll with these two dice. So by total number, I mean if we look at these two dice here where we've rolled a 1 with each die, we know that 1 plus 1 is 2. So in this case, the total number of this dice roll is 2. Now that we have a question that we can use to study this, we need to next make a hypothesis. A hypothesis is just a fancy word that refers to a type of guess. But even though the two have similar meaning, a hypothesis has one important point in that a hypothesis is also called an educated guess. Whereas a guess is just what do we think would happen and that's all. When we make an educated guess, we need to ask why we are making that particular guess. Now, to look at what makes a good hypothesis and a bad hypothesis, let's actually look at the reason why someone would guess that a certain dice roll is the easiest number to roll. Now, let's say that two different people chose two different hypotheses. Let's say that one scientist said that 2 is the easiest number to roll simply because they see, well, these two dice say 2, while a second scientist said, well, maybe 6 is an easier roll to make. Now, why would they have predicted these? Well, we can look at the different possible combinations that you can roll with two dice, and that bit will begin to give us a little bit of a better idea. Now, if you think about the possible rolls that you can get 2 with if you have two six-sided dice, well, you can roll 1 with one die and 1 with the other die, and that's pretty much it. You can't roll a 0 with dice, so this is the only possible roll out of all rolls that will allow you to get a roll of 2. So this is not looking like a very good hypothesis so far. But what about if we take a look at 6? Well, let's say that you roll 2 with the first die and 4 with the second die. 2 plus 4 makes 6. Now, if the order matters, if you roll one die and then the other die, we could also say that you roll 4 with the first die and 2 with the second die, and both of these give us two different options here. Now, what if you roll a 3 with the first die and a 3 with the second die? That also adds up to 6. And finally, if you roll a 1 with the first die and a 5 with the second die, 1 and 5 is 6. And if you do it the opposite way, 5 and 1, that is also 6. So what we can see here by simply looking at the number of possible combinations of dice rolls that you can get, it seems like there are a lot more different combinations to roll 6 than there are with 2. So it's looking like a dice roll of 6 is a much better hypothesis, or rather a much more educated hypothesis, because we can support it with some actual evidence. Once you've made a hypothesis that makes sense to you, the next step is to actually conduct an experiment where we actually do something in order to collect data that we can use to support or confirm our hypothesis. And when we're talking about the roll of the dice, there isn't really anything else we can do other than roll the dice a bunch of times. So that's exactly what the experiment is going to do. Now, if you think about this, if you roll the dice once, is it a good idea to roll the dice once and say, okay, our experiment is done? Well, probably not, because let's say you actually do roll 2. If you stop your experiment there, you are basically concluding that, well, I rolled a 2 this one time, therefore every other time that I roll, I'm going to get 2 as well. That makes sense for about 1.5 seconds before you realize, no, that sounds crazy. So it's probably a good idea to do the experiment more than once for the purpose of accuracy. Now, if we do the experiment more than once, we can see that we can get a large number of different dice combinations, much more than if we were to do the experiment once. So the point is always repeating the experiment that we do for the purpose of seeing, do we get the same result over and over and over again? Is our experiment accurate, and is it precise? Is the mark of a good experiment design. As you do the experiment, what you are going to do is make observations. Now, observations is a noun, and if we convert this to the verb form, we get the verb to observe, and to observe is just a fancy way of saying to see. So when you make observations, you are seeing, what do you see, what do you hear, and even what do you smell or what do you taste during a scientific experiment. Now, in this case, we're just using our eyes to look at the different types of dice rolls that we observe in the experiment, and this, by looking at the total number of each dice roll, you are making what we call a quantitative observation. Now, if you're not familiar with this word, you can get a hint about what it means by looking at the beginning of the word, because we can see the word quantity. Now, when you're describing a quantity of something, you're describing how much of something you have or how many of something you have. The point being that if you can count or if you can measure an observation that you're making, you are making a quantitative observation. In other experiments, like for example, if we were doing a chemistry experiment and observing this blue liquid in this beaker here, you can also make a different type of observation, which is what we call a qualitative observation. And if we do the same thing, if we break this word apart, we can see the word quality within the word qualitative, which is describing the appearance without measured quantity. So if we were to make observations about this liquid in here, well, firstly, we can say that it is a liquid. It's not a solid or a gas. Now, we can't put a number to this, so this would be a qualitative observation. We can also see that this liquid is blue. In other words, we're commenting on the color of this liquid, which means, because you can't describe color with numbers, not yet anyway, that you are making a qualitative observation about the color of the liquid. However, in this case, you can also make quantitative observations. For example, if we look at the measurement here, 300 milliliters, what we are describing is the volume, how much of this liquid we have. If you were to put this beaker on a scale, and if you were to count or measure the mass of this liquid in grams, that would also be a quantitative observation that we're making. Now, after enough of the experimentation is done, and after we've made enough of our observations, the time will finally come in which we will have to analyze our result. When we analyze our result, we are specifically looking at the observations that we make. How many times do we get each of the different dice roll possibilities, and see whether they match our hypothesis. And there are two possibilities as to what can happen. Number one, the results do match our hypothesis, and therefore our hypothesis is correct. It happened exactly as we predicted. Or the results do not support the hypothesis and don't match at all, in which our hypothesis is incorrect. If our hypothesis is correct, if they match the data that we observed, that means that we can write a concluding statement or a conclusion about the importance of this experiment, explaining that the observations that we made match the hypothesis that we made, and match because our explanation about why the hypothesis is there is consistent with the results that we saw. So an example of a concluding statement is that our hypothesis is correct, because it showed that whatever the number of the correct number or total number of the dice roll is the easiest number to roll based on 2 dice. And again, remember that the hypothesis includes y, because that number has the most possible combinations to roll. Now, I'm going to leave this blank here because this is an experiment that you can do by yourselves to see whether you can come up with the correct hypothesis. Now, what if you don't? What if you said that 2 was your hypothesis? Well, that means your hypothesis is incorrect, but that doesn't mean that the experiment is a failure, because what we have learned is that 2 is not the easiest total number to roll, and either way, you have learned something. But if the hypothesis is wrong, we need to go back to it and modify it in such a way where we can more likely arrive at an explanation that is consistent with our results. In the next video, we're going to look at the subject of variables, that being parts of an experiment that change during the experiment. So until then, to make sure that you are familiar with the scientific method, you can try these practice questions here. These are relatively simple. Do you know the difference between a hypothesis and a guess? And can you tell the difference between qualitative and quantitative observations?